Alright, what's up guys? So now let's talk about the commutative property of vector addition. And this property is very simple, and all it means is that the order in which you add vectors does not matter. So if I take vector x and to it I add vector y, the resultant vector that we would get from that addition would be the same as if we started with vector y and then added vector x on top of it. And we touched on this a bit when we discussed the parallelogram law of vector addition, but a little review does not hurt. So to prove this property, let's do it with a diagram. So let's say that we have these two vectors, this vector x and then this vector y. So if we want to find the resultant vector of taking vector x and adding vector y, so first we would draw vector x, and then to its head we would add this vector y. So vector y goes at an angle like that. So this is vector y. So then the resultant of those, make sure I get this pretty smoothly. That's not bad. So this would be the resultant. This would be vector x plus vector y. Now, what if we, instead of starting with vector x, we started with vector y first, and then we added vector x to it? Well, if we start with vector y, it would look something like this. And then adding vector x on top of that, vector x goes this way. And notice how we end up at the same point. So the resultant here would be the same resultant as when we added x plus y. So this resultant here is y plus x. So, in conclusion, whether you're adding x plus y or y plus x, you end up with the same resultant. So the order in which you add vectors does not matter. Now I want to make an extra point on this. First off, we just worked with two vectors here, so the number of vectors you work with does not matter. You could have 3, 4, 5 and rearrange them in whatever way and you would get the same resultant. And we also here only worked with addition, but you could also be subtracting vectors. So for example, let's say I had vector x minus vector y plus vector z. Well, that would be the same as if we brought this negative y in front, maybe brought the z as the second vector, the third vector would be x. We could also bring the z in front, plus x, minus y plus z plus x. Anyway, you get my point. It doesn't matter the order, the resultant vector would be the same in all of these cases. So if you want to maybe prove this, draw out maybe 3 random vectors that are going in different directions, add them in different orders, and notice that the resultant vector that you get would always be the same.